Hey guys, this is Mr. Mitchell coming to you live from my office to provide you with another awesome lesson. Thank you. Thank you. All right, guys, how many of you guys send text messages? Okay, text messages are a simple way. Sometimes we can use these abbreviations to communicate because we don't want to write the entire statement out. So some of these I'm familiar with. I want you to pause the video right now and see how many of these abbreviations from text messages you understand. Again, pause the video and see what you know. Give you 5 seconds. Okay, coming back. We know that this one, talk to you later. Okay, I think this one is let me know. Oh, of course we know this one is laugh out loud. I mean, I don't really want to type laugh out loud. LOL. F to F is face to face. Much shorter, right? Face to face. Be right back. Um, rolling on the floor laughing. I believe that's what that means. I forgot what this one means. B for N. I can't remember what it means right now, but I'm sure you guys know. What about this one? Are you guys familiar with this one? This one means what you see is what you get. All right, guys, so we can use these short messages, abbreviations to communicate longer messages, but these are much easier to text and to type. We're going to use this same method with something else, which is called, we're going to be talking about scientific notation on today. Again, we're going to be talking about scientific notation. Yeah, scientific notation. So scientific notation is taking really large numbers and really small numbers and condensing them. So I did a couple of Google searches. You might say, well, why do we use this in real life? If you Google Christ, you will see you have 417 million results for the word Christ. So a lot of people are seeking Christ online. So it's a lot. But if you search money, wow, 2,790,000,000 people are searching for money. Okay, so this is an extremely large number. So we're going to talk about how we can write numbers like this that are pretty large, or some could be really, really small, and how can we abbreviate our number. Yep, that's what we're going to be doing. So get ready. Let's focus. We're going to go ahead and start with our lesson. So clear your brain. Yes, just flush it all out and get ready for today's lesson. All right, Jason? All right. So here we go. I want you to put this information inside of your foldable. So you're going to write and copy the definition of scientific notation. All right, scientific notation, a number is written in scientific notation when it is expressed as a product in the form of a times x to the n, where a is, well, where 1 is less than or equal to a, and a has to be less than 10. So, what does that mean, Mr. Mitchell? Scientific notation, your number has to be between 1, it'll be 1, and it has to be less than 10. So numbers that are less than 10 are like 9, 9.8, things like that, but it can't be 10. Okay, it has to be less. So we're going to look at what that means. So again, pause the video and you're going to write this down in your foldable. Yes, we're going to write this down. So what I also want you to write down, We're going to look at an example. Okay, if we have the number 4,200,000, how can we write that in scientific notation? Okay, so when you have a number that's already in standard form, the decimal is located at the end of the number. All right, and we're going to move the decimal to where we can make this number between 1 and less than 10. So if I move this decimal 6 places, it's going to be between the 4 and the 2. So this is how I'm going to write it in scientific notation. I moved it here. So I'm going to have 4.2 times 10 to the 6th power. Okay, the 6th power represents my 6 places that I moved. Okay, so this is fairly simple. Okay, again, we're always going to have a power of 10. Okay, so again, we have 4.2 times 10 to the 6th power, and it's because we moved 6 times. We moved 6 times. Okay, so again, number between 1 and I'm going to say less than 10. Less than 10. We also have another type of problem. Make sure you write this in your folder when you have a working understanding of this. We're going to practice a couple of problems, but I want you to be laser focused and understand. Now, these are numbers that are large, 4 million and things of that nature. We also have numbers that are very, very small. So if you look at this number, erase this, we have a very small number. We have 0.0000067. So how can we write this number in scientific notation? So since we see our decimal, we're going to move it to a place where our number will be between 1 and less than 10. So if we move it, if we count how many places are in between, we have 1. Get my pen. 1, 2, 3, 4, 5. So if we move it 5 times, we put it right there. So it'll be 6.7 times 10 to the negative 5th power. Okay, since this number is very small number, we're going to go ahead and move our decimal 5 times, and then we're going to put the exponent according to how many places that we move. Now I'm going to show you another way as well that some people like to use. So now if I take my decimal and I move it between each number, 1, 2, 3, 4, 5, I know I have to move it 5 times. So it'll be 6.7 times 10 to the negative 5th power. Okay. So let's look at a few examples of what we have. Again, this is something that I want to draw your attention to. Very important. Kind of just shows what we just went through. If you have a number that's in scientific notation and they want you to write it in what they call standard form, just move your decimal 1 time. So this number is 62. So again, this tells me how many times to move my decimal. So since I only moved it once, my answer will be just simply 62. Okay. Now, we have this number. They say, okay, write this number in standard form. Then I'm going to move my decimal 8 times. And when I move it 8 times, I get 149,600,000. Okay, so if you look, my decimal was here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you just have to fill in the blanks with zeros. And the same is true when we have a negative. Okay, we move the decimals here. 1, 2, 3. We don't need the leading zero, but it's not wrong if you put it. Okay, same thing is true for this one. So again, pause this. This is additional notes that help you. Just some handy tips to help you out along the way. All right, so now express each number in scientific notation. So I have my tool, and you can use this as well. All right, I know my decimal is there. So if I move it, let's say 1, 2, 3, 4. So I have 4 place values. Okay. So the answer for this would simply be 2.95 times 10 to the 4th power. Very simple, guys. If you have any questions, simply raise your hand. I'll come over and assist you. Now we have our decimal here. Man, this is a very small number. So let's go ahead and count. We have 1. You can count the number of places or the number of spaces in between. Let's count for this one the number of spaces. The number of places. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so my decimal will be between this 0 and 4. So my answer, I have 1, 2, 3, 4, 5, 6, 7, 8. So this will be the answer for this one. It will be 4.3 times 10 to the negative 8. Again, if you have any questions, please let me know. But if you say, I'm starting to get this. Thank you. Yes, thank you. Thank you, Miss Mitch. I get it. It's awesome. I want you guys to pause the video at this time. Pause it. And I want you to try these 3 problems. After you try the problems, I'm going to go ahead and reveal the answers to you. But I want you to try them first. So go ahead, pause the video, and try these problems. Thank you. Welcome back. If you pause the videos, your first answer should be 3.9 times 10 to the 8th power. Number 2 is 2.73 times 10 to the 5th power. And this last one would be 5.2. Remember, this one is negative exponent. 5.2 times 10 to the 5th. If you had all 3 of these correct, you're on your way. If you had one or more wrong, we got to definitely get you some help. Just raise your hand and I want to clarify and help you with this. Moving on. All right, now we have a little bit of different type problem. It says express each number in standard notation. Again, express each number in standard notation. So I know that this number is a large number. It's not negative. So I'm going to start with 2.1. Now it says I need to move 5 places. So 1, 2, 3, 4, 5. You could say these are like 0 holders. So we can put 1, 2, 3, 4. So now I'm going to write the number. And that is my answer, 210,000. So what about if we have 6 0.8 times 10 to the negative 6. I'm going to go in the opposite direction 6 times. 1, 2, 3, 4, 5, 6. And I'm going to put my zeros. 1, 2, 3, 4, 5. So 5 zeros. And your decimal is going to be here. That's it, guys. That's how we take a number and write it in standard form. What I want you to do at this time, I want you to practice with these 4 questions. And then I'm going to give you the answers. Yes, I'm going to give you the answers. But I want you to pause it first. And then when you come back, I'll reveal all of the answers to you. So go ahead and pause the video now. And then come back. All right, I'm going to go ahead and reveal the answers. Here we go. Number 9. Number 9. 254 million. Wouldn't you like to have that much money? Number 10. Write number 10 right here. Number 10. 34 million. All right, I'm going to write number 12. Well, let's do 11 now. Number 11 would be a decimal, 3 zeros, 153. And number 12 would simply be 5 zeros, number 12. 1, 2, 3, 4, 5. Don't forget to put your decimal, 289. And that is it, guys. That is it, guys. So if you have questions related to this, raise your hand. I want to make sure that you understand what you're doing. Enjoying math and just having a great time. Enjoying math, yes. It's not fun. I want you to enjoy math. Okay, guys, I'm going to do part 2 live with the class. It's very simple. I'll talk about division with scientific notation. You will have homework that will be due on Friday before you go into spring break. Thank you. You have been a great audience. Great audience. Yes. Don't break anything, and I'll see you next time.